Hello students, welcome to EPG Pathshala. I am Dr. Manjula Sharma from University of Delhi. Today we are going to discuss about the module Transducers from the paper Measurement and Instrumentation. From this module, students will get to know a lot about the transducers. First of all, transducers will be introduced. Secondly, classification of transducers as active or passive will be explained. Thirdly, the classification of transducers as analog or digital will be shown. Then, electrical and magnetic phenomena used in the transducers will be discussed. Then, the criteria for selection of transducers will be discussed. There will be basically three criteria like fundamental, environmental, and physical conditions which will decide the selection of transducers. Next, we will study the compatibility of transducers with the next stage in the measurements, and at the last we will discuss the smart sensors. Students, what are transducers? So, while making measurements, the quantity to be measured is called as measurand. First of all, comes in contact with the detector. The measurand or the input signal is basically the information which we require from the measurement system. This information can be present either in the form of a physical phenomenon or an electrical signal. This information is then sensed and translated into a suitable form for their recognition in the further stages of the system by the detector. Energy is required in order to detect and convert the input signal or information from one form to the another. To reduce the loading effects, efforts are generally made to supply energy to the detector from the external sources so that no undue energy is being extracted from the input signal, and the output of detector is faithful representation of the input. Broadly speaking, transducer is a device which receives energy in one form and transfers it into another convenient form or state. For example, the diaphragm produces displacement on application of pressure. Both pressure and displacement are both mechanical form of energy. Still, displacement is easier for the measurement point of view. Similarly, a thermocouple, which is a junction of dissimilar metals, generates electrical signals with a difference in temperature. Thus, it acts as converter of temperature difference or heat energy to electrical energy, which is easier for measurements. Thus, a thermocouple may be called as a temperature transducer. Transducers. The sensors or the transducers may be electrical, mechanical, acoustic, optical, thermal, magnetic, nuclear, chemical, or any of their combinations. Out of these types, electrical signals are most preferred due to the following reasons. First, devices such as op-amps can be used to ensure a minimum loading of the system. The electrical signal can be easily conditioned as required. Third, the measurements can be performed remotely and also multiple times. Fourth, data acquisition for the electrical signals is largely observer independent and can be controlled precisely using computers. The transducers can also be classified into two main categories. First category is the active transducers and the second category is the passive transducers. So students, let us see the active transducers. These are basically self-generating devices and do not require any external source of energy to be driven. Active transducers basically convert one form of energy to the other without requiring any external source for their excitation. These can be further divided into the following categories. First, the thermoelectric transducers. These are based on the property of thermoelectricity generation. Devices such as thermocouple, thermopile, and thermocouple gauge are based on this property for their application in the measurement of temperature, radiation pyrometry, or temperature of distant objects and low pressure respectively. Second is piezoelectric transducers. These are basically on the property of piezoelectricity generation. Devices such as piezoelectric transducers are based on this property for their application in the measurement of pressure. Third is the photovoltaic transducers. These are based on the property of photoelectricity generation. Fourth kind of devices such as the photodiode in combination with the diaphragm are based on this property for their application in the measurement of pressure. Next is the electromagnetic transducers. These are based on the property of electricity generation by moving a coil in the magnetic field. Devices such as electromagnetic pickup are based on this property for their application in the measurement of flow. Last type of transducers are the galvanic transducers. Students, now let us see the second category of transducers, that is the passive transducers. These transducers need to be excited from the external source of electrical energy for their working. The energy derived from the measured signal produces a change in the electrical state of the passive transducers, which can further be assessed easily. Consider a photoresistor. It can be excited by an external cell and the voltage across it can be easily measured. When light of sufficient intensity is turned on, the resistance of photoresistor changes, which ultimately alters the voltage across it. Depending upon the principle of operation, passive transducers can be further classified as follows. First, resistive transducers. Second, inductive transducers. Third, capacitive transducers. Fourth, magnetoresistance transducers. Fifth, photoconductive transducers. Sixth, thermoresistive transducers. Seventh, elastoresistive transducers. Transducer devices such as potentiometers, strain gauge, Pirani gauge, hot wire anemometer, platinum resistance thermometer, thermistor, photoconductive cell, or light dependent resistor, that is LDR, in combination with a diaphragm are a few examples of the devices which are based on the property of resistance variation. These devices find application in the determination of displacement, small displacements useful in the measurement of strain, pressure, force or torque, to measure low pressure, flow, temperature, pressure, etc. Devices such as linear variable differential transformer LVDT, synchro, and eddy current gauge are based on the property of inductance variation for their application in the measurement of displacement and angular displacement. Capacitance variation based devices such as capacitor gauge and dielectric gauge are used to measure displacement. Electrical transducers have far more adaptability to the instrumentation than those of the transducers, which generate analog output signals. Electrical transducers can be the first constituent element in a measurement system and hence are called as primary transducers. However, many times transducers are preceded by mechanical instruments in the measurement system. Such transducers are called as secondary transducers. It should be noted that the precision of the data observed by a measurement depends mostly on the transducers, as they are the sensing elements in the system. Now students, let us see the analog and digital transducers. Classification of the transducers can also be done on the basis of the type of output, which can be either in the form of continuous signal as a function of time or as discrete steps. First, the analog transducers. The transducers which convert the physical phenomenon into an analog signal which is a continuous function of time. Examples of analog signals are LVDT, strain gauge, thermocouple or a thermistor. Next is the digital transducers. These transducers convert the input physical phenomenon into an electrical output, which is in the form of pulses. This transducer uses digital code marks to identify the position of a movable piece by a binary system of notation. The position is given out as a train of digital pulses. Now, let us see the electrical phenomena used in the transducers. The transducers may be classified into different categories depending upon the principle employed by their transduction elements to convert the physical phenomenon, that is input, into output electrical signals. The different electrical phenomena employed in transduction elements of transducers are listed below. These phenomena may be combined with appropriate primary sensing elements, that is detectors, to produce a variety of transducers. These phenomena are resistive, inductive, capacitive, electromagnetic, piezoelectric, ionization, photoelectric or photoemissive, photoconductive or photoresistive, photovoltaic, potentiometric, thermoelectric or thermovoltaic, and electrokinetic. Now students, let us see the magnetic effect based transducers. Magnetic effect based sensors are gaining a lot of attention lately because of their diverse applications. For example, reluctance based transducers are based on Faraday effect, and magnetoresistive transducers utilize Thomson effect. Transducers which are utilized in combination with piezoelectric elements for magnetometers and potentiometers are based on the principle of Joule effect or magnetostriction. Torque or force, displacement, and level measurement are based on Wiedemann effect. Magnetoelastic and magnetogalvanic sensors are based upon Villari and Hall effects, respectively, and squid magnetometers are based on Josephson effect. Based on the principle of energy conversion, magnetic transducers can also be classified as active and passive transducers. Now students, let us discuss the Joule effect or magnetostriction. Magnetostriction refers to the property of materials ferromagnetic which expand or contract in the presence of magnetic fields. These materials have crystalline structure intrinsically which is divided in several domains, each of which has a uniform magnetic polarization. In the presence of external magnetic field, the domains become oriented with their axes almost parallel to each other. Also, the domain boundaries also get shifted and thus a change in the dimension of material is observed. Magnetostriction coefficient lambda refers to the fractional change in the length of the ferromagnetic material with the application of magnetic field. The change in length can either be positive or negative. That is, the length can increase or decrease, and the value of lambda is of the order of 10 raised to minus 5. There is a dissipation of energy in the form of sound which is related to the elastic strain energy associated with deformation. Vibrators, ultrasonic vibrations as sound waves or as ultrasonic waves in liquids utilize magnetostriction effect. Now, let us see the Villari effect. It is reverse of magnetostrictive effect as it refers to the permanent change in the magnetic permeability of the material by generating stress in the magnetostrictive material. Magnetostrictive displacement sensors and level sensors are based on the Villari effect. Students, now we should see the selection criteria for the transducers. While selecting transducers for a measurement, few parameters must be taken into account, which can be classified as fundamental parameters, environmental parameters, or the physical conditions. First, let us see the fundamental parameters. These fundamental parameters can be classified as follows. First, the selection of transducers will depend upon the type of measurement. Second, the range of measurement will also decide the type of transducers to be used. Third is the required precision during transducers selection will depend upon the following factors. A. Allowable nonlinearity effects in the transducers. B. Allowable dead zone effects present in the transducers. C. The frequency response of the transducers. And D. The resolution of the transducers. Environmental parameters also play a significant role in transducer selection. It includes consideration of the ambient temperature for the measurements. Second, the corrosive or non-corrosive atmosphere where measurements are to be carried out. Third, the shock and vibration to be withstand during the measurements. Physical conditions of the transducers and also the measurement are very much important for the selection of transducers. These must also be taken care of. First, the room or available space to mount the transducers is important. Second, whether the measurement is static or dynamic will also decide the type of transducers to be used. Third, how much energy can be extracted from the measurement to do the measurement without loading is an important parameter for deciding the transducers. Now students, let us see the compatibility of the transducers with the next stage in the circuit. The transducer must be chosen properly so that it is compatible with the requirements of the next stage in the measurement system, and the following points must be taken account of. First, there should be impedance matching of the transducers with the instruments to be used for measurements. Second, there should be excitation voltage matching with the next stage in the measurement system. Third, also there should be sensitivity tolerance matching with the next stage in the measurement system. Transducers in general can be prepared from a variety of materials, but in order to have application in practical instrumentation, they must adapt the following requirements. First, they should have ruggedness to withstand the overload. Second, there should be linearity in their measurements. Third, the results should be repeatable. Fourth, the transducers must be stable. Fifth, the transducers must have good dynamic response. Sixth, the transducers must have convenient instrumentation. So students, now let us learn about the smart sensors. Transducers or ordinary sensors help us in sensing or controlling the process parameters such as temperature, pressure, strain, flow, pH, etc. Smart sensors provide functions beyond all of this. First, a smart sensor acquires the data from the instruments. Second, the conditioning of the signals is also done by the smart sensors. Third, the smart sensors can convert the measurement into the attributes units, and also the smart sensors transmit the data to a network by wireless method or through wired line. The smart sensors also possess built-in digital interface that provides a communication channel with the network control. A functional smart sensor system consists of two main components, namely Transmitter Interface Module (TIM), which contains physical transducers and data acquisition system, and Network Capable Application Processor (NCAP), where control and data correction take place. Now let us see what are their functions. The transmitter interface module performs the following functions. First, analog signal conditioning. Second, triggering. Third, analog to digital conversion. Fourth, command processing. Fifth, TEDS storage. And sixth, data transfer and communication. The functions of network capable application processor are: first, message encoding and decoding; second, detection and control of transmitter interface modules; third, correction and interpretation of TEDS data; and fourth, message routing and interface control. So students, let us summarize what we have learned in this module. In this module, we have introduced the transducers, which are basically devices that receive energy in one form and transfers it into another convenient form or state. We studied the classification of transducers as active or passive, and also classification on the basis of being as analog or digital. We discussed the electrical and magnetic phenomena used in transducers. Also, the criteria of selection of transducers were discussed, which were mainly the fundamental parameters, environmental parameters, and physical conditions. We understood the parameters necessary for the compatibility of transducers with next stage, like impedance matching, excitation voltage matching, sensitivity tolerance matching. At the end of the module, we discussed the smart sensors. Thank you.